system, linear time invariant system can be represented by this x plus bu y equal cx. Okay, someone also says that it can be written also in this way. Okay, but why have I written y equals cx and I've not written du? Can I do it?
Sometimes.
Let's see if you know. Why can I do it? I can do it because d is known and u is known. So you can write it as y minus du equals cx, and this is the new output. So you can always reconduct the system to only the blue part, because du is known. So we can eliminate this part and concentrate on this. This book also does not consider this, but it is just a simplification.
D is known.
B always known.
D.
D is known, yes, it is the system. A, B, C, D is known.
Okay, yeah.
Okay, so A, B, C, and D is known, is the system. And it is the main thing that you have to know when you have to use the Kalman filter. Now, the Kalman filter starts from the knowledge of the system, but includes two terms, just to be consistent with this one. I wanted to use one which is called wk and another which is called v. Okay, another thing, this is the so-called continuous, but we will actually use this one. A xk plus 1 is equal to a xk plus b u k plus b k and y k, which equals z here. He prefers to use it as z. Zk equal h x k plus v k. Okay, I prefer to use. Remember, this is the continuous, this is the discrete, and actually this a and this b are not this a and this b. They are different. I put just the same because the book calls it A, but actually you should write A, C, and B, C, and C, and this is A, D, and B, D, and C and H. Actually, C and H are really the same, but be careful from this and this. There is a slight difference. Why? Because when you make x dot and you make the Euler, for example, transformation, then you have to divide the xk and the x plus 1. So here you will have that AC will have some component which depends on the time of sampling. And so AD becomes different from AC. So we forget this, for example, for the time being, and we consider only this okay, now WK is a noise on the states, and let's see how they call it, and VK noise. This is called noise on the measurements. And this is is noise on the state transition. Okay. You all know that the noise can be represented by a matrix which is called autocorrelation matrix. You know, just to remember what is an autocorrelation matrix, you take, for example, let's take this W. Wk is a vector. These are vectors. So, for example, it is W1, W2, W3, W4. It can be N. The autocorrelation matrix starts, first of all, from this. I take Wk and Wk transpose. So it would be W1, W2, W3 and W4 multiply W1, W2, W3, W4. Okay? So, what kind of matrix is this?
Square.
A square matrix, which is 4 by 4. In particular, you have W1 to the power of 2, W1, W2, W1, W3, W1, W4, and this we have W1, W2, W1, W2 to the power of 2, W2, W3, W2, W4, and then W3, W1, W3, W2, W3 to the power of 2, W3, W4, and W4, W1, W4, W2, W4, W3, and W4 to the power of 2. This is a matrix which is symmetric, okay? And let's see if it is not a very actually it is not linked strictly to Kalman, but I would like you to tell me what is the rank of this matrix.
4.
Rank. What is the rank of a matrix? First question. The rank of a matrix is the number of
Non-zero.
the rank of a matrix is
You look for number of non-zero rows.
yes, but after the transformation. But the definition, it is a consequence of the definition of rank of a matrix.
If there are any zeros present in the matrix,
No, because you can have a zero in the matrix, and this does not mean that it is of does not tell the rank. I know what you want to say, but it is not that. It is a consequence. What is the this is something you have to know. Linear algebra must be known like that if you want to know control. I tell you, the rank of a matrix is the number of independent rows or independent columns. And the number of independent columns and the number of independent rows for a rank is always the same. So, how many rows do I have here?
4.
Or 4 columns. So, what is the rank?
4.
4. No.
4.
I just said the number of independent. So the question is, how many independent of this?
0. They all tied into each other.
How? So how can there be a matrix equal 0? If a rank is 0, it means it is the
16.
0, 0.
1, 2, 3, 4.
Okay, if it were 0 rank, then it means it is the 0, only the matrix 0 as a 0 rank by definition. So this can have either like rank 1, or rank 2, or rank 3, or rank 4. I would like to know what it is according to you.
Independent,
Independent.
I think it's rank 1.
Why?
Because all elements are, if you look at it, like for example, in row 1, you'd have W1, 2, 3, and 4. All of the rows have each of those elements tied in. So there is nothing independent of each other. None of the rows are independent.
But can be 3, 2, or 1. Why is it 1?
There is, if,
Let's see.
that's why I thought it was 0.
Zero
There is nothing independent, yeah. None of them are independent.
Professor, it will depend on the values they have.
Let's try to write again this. This can be written. What is common here? W1.
Yeah.
So I can write W1
Yes.
multiply
By
Double
1 to
one.
4. The vector.
W2, W3, and W4.
Yes.
And this is the first column. What is here common?
W2.
This is 2. W2, W1, W2, W3, and W4. What about here? W3, W1, W2, W3, and W4. And what is the other column? W1, W2, W3, and W4. So, what happens? That each column is a multiple of the same vector.
Yeah.
So they are all dependent from one vector, which is this one.
Yes.
So for this reason, this is important. Can I leave you a moment?
Yeah.
Hello.
That's why I was thinking that it's rank 0, but you told me it's not possible. Because everybody is related to each other, Prof. Every number is related. It's like they're all the same family. In fact, we should invite Ilonke. Those fellows should also come.
Shamal Pawan, no?
Pawan हमने इनका कुछ करे, I don't know, but the other guys, Shamal, professor student should come. Shamal and what's the other guy's name? Shana. Because they will use this. Pawan, he won't use heavy mathematics now. He'll be more.
No, we learn, we teach them. And we learn to time.
Yeah.
The same thing that we said, we can repeat again, you will learn to time.
In fact, when professor goes away, we should still have our own research group. Just of us, 4 of us, because we'll be here. So we should still continue with some, like this kind of. Satu yang belum Arduino mikir lagi. Kenapa jadi heavy setting dah?